Go through your pre and mid assessment here. Even if you did well on this, you may learn something from my explanation as we go through. Remember, on Thursday, you guys are going to take either the green or the yellow assessment of this. And so the yellow means that you're someone that's been in the yellow and red. You can maybe balance equations. You can identify some reaction types. You're kind of getting to the point of prediction, but you're not to that point yet where you're able to look at a couple items and say, hey, I'm going to predict these products, and these are the products that would get me this precipitate and that kind of stuff. Those people that are ready for that are going to be in green. And then green, you guys would be doing that predicting kind of some lab setting questions, even though you wouldn't be in the lab yet. That'll be after break that you'll get to that high level of an A. But you would also be looking at some of the net ionic stuff from the other day. So this video that I'm going to do here is just going over this assessment right here that you guys have already done. I'll give a few hints and those kind of things. And then those of you that are on the green, I'll have a separate one if you want to watch that one too. You are taking this tomorrow, okay? So please let me know if you guys have any questions, and I'll try to get back to you as soon as I can. Even if you need me to audio record something or video record how to do something, I can do that as well too. So I hate being gone. It's out of my hands right now. So, okay, so let's look at problem number 1. It says write the balanced chemical equation and tell the type of reaction for heating oxygen difluoride gas, which produces oxygen gas and fluorine gas. Okay, so oxygen difluoride, oxygen, oxygen, and di means 2. There are 2 fluorine. Remember, whenever you have something that says mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, you do not do anything with charges. You just do what it tells you. Remember, these are shared. They're covalently bonded. They're molecules. So if it says oxygen difluoride, that means there's 1 oxygen. It means there's 2 fluorine. That's it. That's all you do. Okay? Produces. That's narrow. Oxygen and fluorine gas. Okay. Now, we take a look up here and it says fluorine and oxygen are diatoms, which means that if they are by themselves, they are a 2. Here are all your diatoms. There's 7 of them. There's hydrogen, there's nitrogen, there's oxygen, and fluorine, chlorine, bromine, and iodine. It's the halogens there. So it makes a 7 on your periodic table with the exception of the hydrogen. He's clear over to the left. So there's 7 diatoms. That means, once again, when these guys are by themselves, they are so reactive, they're so electronegative that they will bond with another one of themselves instead of being alone, okay? These are the only guys that do it. So notice right here, oxygen is not by himself, so he's not a 2, okay? Fluorine's only a 2 because that's what I told you up here it was happening. It's only when they're by themselves. So please put these on your periodic table, circle them, star them, whatever, so that you know if you write out an equation that just has one of these by himself, he's going to be a 2. All right, so now let's go ahead and balance. I have 1 oxygen and 2 oxygen, so I'm going to put a 2 right here. That fixed the oxygen, but now I broke the fluorine. So 2 times 2 is 4. I only have 2 over here. I make that a 2. So I check and make sure I'm good. 2 oxygen, 2 oxygen. 2 times 2 is 4 on the fluorine, 2 times 2 on the fluorine. Okay, notice we only have 1 reactant. No plus signs over here, just 1 reactant breaking down into a bunch of things. This is a decomposition reaction. If you start with one thing and break down into a bunch, and I don't care how many things we break down, we could have 3, we could have 4, we could have whatever, it's going to be decomposition. So here's another example of decomposition reaction. Hydrogen peroxide, the stuff that you put on your cuts that is in a brown bottle. Okay, hydrogen peroxide will break down into water and oxygen gas. Okay, I can look and see I had 2 hydrogen, 2 hydrogen. I have 2 oxygen, I have 3 on this side. So I'm going to double him to get to 4. Double that. I have 4 hydrogen, 4 hydrogen, 4 oxygen. 2 plus 2 is 4 oxygen. Once again, I had a decomposition reaction. So remember, if there is only one thing to the left of the arrow, one thing, no plus signs whatsoever, it's a decomposition reaction. Okay, so that's problem number 1. Problem number 2, the reaction between methane. So I'm going to just write up here. Methane, remember, is CH4. He's a hydrocarbon, the simplest hydrocarbon we have. It's the gas that comes out of my valves in my classroom. Okay. The reaction between methane and oxygen gas is what type of reaction? Okay, so methane and oxygen. Remember, oxygen was a diatom, so he's by himself. All right. Anytime you have oxygen as a reactant, it is a combustion reaction. Now notice I said oxygen as a reactant, not oxygen in a compound, okay? He's oxygen as a reactant by himself, okay? He has to be to the left of the arrow where he's just an O2. He's not combined with anyone. That's a combustion reaction. Now, more importantly, so we can answer this question already. It's a hydrocarbon combustion. The last part of this is the hydrocarbon. So notice the oxygen is reacting with a hydrogen and a carbon. This will produce every single time carbon dioxide and water. So every time you have a hydrocarbon combustion reaction, these are the products you'll get. I'll do another one right here. What if I have propanol, C3H8O, and I tell you it burns in air? There's a lot of stuff in air, but if it burns, the only thing it's going to burn with is oxygen. Oxygen's a diatom. Look, I have a hydrocarbon. Who cares that it's an alcohol? Who cares there's an O there? Because I have a hydrocarbon. Any hydrocarbon reacting with oxygen will produce carbon dioxide and water every single time. I don't care how big these get. I don't care how ugly they get. If you have a hydrogen and carbon plus an oxygen by himself, you will always get carbon dioxide and water, okay? And that's what we call a hydrocarbon combustion. Hydrocarbon combustions are the easiest ones that we have to predict what the products will look like. They're the toughest ones to balance. So let's just take a second to balance this, even though that's not what the question asked, but we're going to do it. You have 1 carbon, 4 hydrogen, and 2. So I make that a 2. That gets me 4. So now I check my oxygens. 2 plus 2 is 4. I put a 2 there. We're good. Everybody's balanced. 1 carbon, 4 hydrogen, 4 hydrogen. 2 times 2 is 4 oxygen. 2 plus 2 is 4 oxygen. Good. That wasn't hard. Let's look up here. Okay. So carbon has 3. So I'm going to come over here and put a 3. Hydrogen has 8. I have 2. I put a 4. So 3 times 2 is 6, plus 4 is 10. Okay, well look, you got 3 on this side. If I take off this oxygen right here, so 10 minus 1 is 9. 9 isn't going to get divided by 2. So I'm going to just write this 9 here for a second because we were looking for 9 oxygen. I'm just going to put it there. Okay, what happens when you've done everything that you can and somebody won't balance? You go back and double everything. And oxygen is going to be notorious for this. Okay, so if you've done everything and you've got somebody that's odd, go double. Double that to 2, makes this go to a 6, makes this go to an 8. So let's check and see if we're good so far. 2 times 3 is 6 carbon, 6 carbon. 2 times 8 is 16, 8 times 2 is 16. 6 times 2 is 12, plus 8 is 20. There's 20 oxygen on this side. There's 2 right here. So 20 minus 2 is 18. 18 divided by 2 is 9. Remember that number we were looking for? When you do hydrocarbon combustion reactions where you're trying to get this oxygen to work, every single time that number you were looking for here will always be what goes right there when you go back and double everything. We were looking for 9 oxygen. We go back and double. There'll be 9 oxygen right there. Okay? All right. Going down to the next problem, number 3. Classify the type reaction. So P4O10 plus H2O yields H3PO4. I notice that there's only one thing to the right of the arrow. There's only one product, no plus signs. This is synthesis, okay? If you only have one product, one thing to the right of the arrow, no plus signs to the right of the arrow, then it's synthesis. You synthesize something and produced one product. Decomposition, remember, was the opposite. So we go back up here. This was a decomposition reaction because we only had one reactant, and it broke down to multiple products. Next question. Write and balance the type of reaction for the following equation. Aluminum reacts. So I'm just going to go aluminum, and reacts means plus. Copper 2 chloride. So I'm coming down here. Copper 2 means he's a charge of 2. Not that there's 2 copper, but that he has a charge of 2. Chloride is chlorine. Chlorine on your periodic table is a -1. So what does copper 2 chloride look like? CuCl2. Okay? To produce. All right, I'm not even going to look at what it tells me because I want you to start looking at how to predict this. So we're just going to make that go out of the picture for a second. So aluminum, if he's bonding with someone, is a 3 positive. Aluminum right here was by himself, so there is no 3 positive. There's nothing. He's fine. He's okay, alone, okay? But I noticed that if aluminum did want to bond with someone, he's a cation of 3 positive. Copper's a cation of 2 positive. Notice you have 2 cations and only 1 anion. This is a cationic single replacement or single displacement. Both are acceptable answers. It's whatever you feel more comfortable with. Some people like replace because they know the cation replaces the other one. Some people like displace because they think it's displacing the other one. He's booting him out of the way. It's whatever you like better. I don't care. Okay? So I'm going to predict what the product should look like, and then we'll go back and see if we did it right. So if copper was with chlorine, aluminum is now going to be with chlorine. So if Al is a 3 and chlorine's a -1, aluminum is going to be AlCl3 for aluminum chloride. And then, because these two switched, copper's left alone. Let's go back up and look at the problem. Aluminum reacts with copper 2 chloride, CuCl2, to produce, there's your arrow, aluminum chloride, AlCl3, and plus copper. We predicted right, okay? You've got to be able to recognize the equations first, what type of reaction it is, then you can start predicting the products. So now let's balance it. I've got 1 aluminum, 1 copper, 2 chlorine, and 3 chlorine. The closest number 2 and 3 have in common is 6. So to get to 6, I'm going to go 3 here, 2 here. Well, that's great that we fixed the chlorine, but we just broke the copper and the aluminum. So now I have 3 copper, 3 copper. I now have 2 aluminum, 2 aluminum. My coefficients are 2Al plus 3CuCl2 produces 2AlCl3 plus 3Cu. All right. Next question. Which coefficients correctly balance this equation? So I'm going to write it up here. Magnesium plus phosphorus happens to be P4, produces magnesium phosphide, which is Mg3P2. Okay, so I've got 1 magnesium, 3 magnesium. I could fix the magnesium, but look, I'm going to have to fix the phosphorus anyways, so I'm going to wait a second. There's 4 phosphorus, there's 2 phosphorus, so I'm going to put a 2. That gets me to 4. 2 times 3 is 6. I now put a 6 here. 6 magnesium, 6 magnesium. 4 phosphorus, 2 times 2 is 4 phosphorus. Last thing I want to tell you, even though it didn't ask it, we produced one product. One product is a synthesis reaction. All right, so we come down here, my coefficients were 6, 1, 2, and it would have been a synthesis reaction. Okay, in the reaction between barium nitrate and sodium sulfate, which product found would be a precipitate? This is the lab you guys were doing yesterday. So I'm going to go ahead and do this first of all. Maybe. We're going to go right up here, sorry. Barium nitrate, he's a 2 positive, okay? Nitrate's a -1. And then the other substance was sodium sulfate. Sodium's a +1. Sulfate is a 2 negative. Okay, so barium nitrate is BaNO3 parentheses 2 plus Na2SO4. All right, how to know if something's soluble or not? Here's your hints. Nitrate, NO3, will always, 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 always be aqueous. It'll always be in solution. So he's in solution. Okay? Sodium, anything in family number 1, lithium, sodium, potassium, rubidium, cesium, all of those guys. Anybody in family number 1 will always be aqueous because it's in solution. So this guy's aqueous because he's with a nitrate. This guy's aqueous because he's family number 1. Now let's look. You've got 2 cations and 2 anions, so this is a double displacement switch. So on the other side, I'm going to end up with BaSO4, because look, there was one, or Ba was a 2 positive, SO4 is a 2 negative, so it's just equal, plus Na is a +1 and NO3 is a -1. Na, NO3. Oops. Okay, think about what we just learned. All first family and all nitrates are always aqueous. Aqueous. That means this guy formed the precipitate. If you were told that a precipitate was formed, okay, then it's the one who does not have family number 1 or nitrate. Now, there are more rules than this, and that's what you guys are doing in the lab, but this will get you by for tomorrow. So notice, barium's not family number 1, sulfate's not nitrate. He's my precipitate. I could go through and balance this. I need 2 NAs, gives me 2 NO3s. Now we're balanced and life is good. So let's come back. We're looking for barium sulfate as a precipitate. Barium sulfate as a precipitate. Like I said, anything in family number 1 is going to be aqueous. Anything that has nitrate in it is going to be aqueous. I'm going to stop the video here for a second and do another video because I just don't want to get the video too long. All right, so I'll post the next video here in a second.